Okay, so we're going to look at this again now that we've got that over with. And again, this idea of describing it through the whole range, right? So you really need to, just looking at it in general, like Michaela had said, this one looks like it's rather moderate.
Positive.
Yep. Let me just delete this stuff here. We don't really need it. So it is moderate. It is positive. Is it, what else about that positive?
It's not linear. It's
Nonlinear? What do you think it would be?
exponential.
I'd say it's probably log. But again, the best way to go about that is go ahead and plot the thing and try a few different trend lines, see which one actually fits best, and then you can go back and change the word, right? It's not that hard to go back on that.
Yeah, it does level out as like a little drop.
Yep. So again, this idea that it's positive, it's nonlinear, it's probably logarithmic. So why would it be logarithmic? Describe to me why you notice this would be a logarithmic.
Because it goes up, but even
Yeah, increases rapidly at the start.
Has a slight increase in the people.
For how long? For the, how long? First year? First year. You might say 2 years, depending on the person. Both would probably be okay. And then levels off. Right? So let's talk about just that relationship throughout the range now, this idea of what it means to talk about it throughout the range. So we have said here, overall it's a moderate relationship. It is positive, nonlinear, probably log. But take a look at the graph and try to break it into categories there. Around that 1 year mark, you notice that the relationship goes from a little bit stronger to a little bit more broad, right? So we can come back in and say, you know, I notice the relationship is strongest because there's less scatter from 0 to 1 years, and then it's more moderate after 1 year. And you know, take a look on your graph and see if you can notice that there's big chunks. Or another thing to watch out for is if it's a non-constant scatter, which is another thing we could say here. This is non-constant. Because in a sense, it starts stronger and gets worse as time goes on. Okay, so thinking about that throughout the range, and if it is non-constant scatter, you can talk about up to what point is it strongest, and after what point does it start to become weaker or more suspicious or weird looking, right? So questions on that one about what I mean by through the range? So you need to get specific about the time frames, about how many years or how many weights or whatever it is along the x-axis. Use that x-axis and look along it, scan as you go and see where does it get better or worse. And it might go through 3 or 4 stages. It might be really strong at the start, then kind of crap with a bunch of outliers and a more moderate relationship, and then maybe it gets strong again at the end. You know, don't be afraid to look at that a little bit as well. Okay? If we chuck our trend line on it, oops. Not that I can draw one as well as Excel does, but let's say my logarithmic trend line does something like that. What would you say about this one, describing it throughout the range?
It's already close to the trend.
Okay, so would you say moderate or strong? What would you say?
It's not strong after 1 year.
I'd say strong to moderate. You can kind of waffle on this a little bit, and in this idea that, you know, in this case, it is reasonable because it follows that trend. Like, you can get the idea pretty well of what's happening, but there is some reasonable scatter there as well. So, does start strong, ends moderate. Our reasons for this is scatter, well, just for this one, near the trend line. Is it equally above and below usually? Reasonably. And again, this is just my hand-drawn one, so in this case, it'd say it's, you know, relatively equal scatter above and below the line. And then let's break that down throughout the range. Where is it good? Where is it bad? What's going on? Yeah. So for the first year, this relationship fits the trend line strongest. I probably don't need to be writing all this because I'm just saying it, but fits the trend line strongest in that first year because the scatter is closest to the line, so scatter very close to line, trend line. And then after that, exactly that idea, after 4 years, so, sorry, after 1 year, what happens to the scatter? Yep, scatter increases. More range of heights for any year. Right, so we see that more scatter. Yep.
When we refer to like strong and weak, what exactly are we talking about? Like true,
In this one, this is the strong or weak fit to line. That's really what you're trying to emphasize there, is how well does that line model the data? You know, as we talk about it, the trend line is trying to model what's going on, trying to give you a best guess throughout the whole range what's going on. So yeah, good question. That is about how close it is actually to the line, the fit to the line, and how well that line represents what's really going on. So it's about that representation between the two. Because again, we're going to use that line to do what? Make predictions. And so we're going to predict, we want to predict on something that models reasonably what's actually going on there. And so that's why we need to talk about how strong that is. So if I was going to make a prediction then, let's predict for half a year. You'd put that into your equation, y equals something ln something or other. You get a number. I don't know what it is. But my prediction is going to be right there. What kind of range of values would you give for that prediction? Yeah, I don't know what the numbers are, but let's say it would be a relatively small range. So let's call that, well, just for the sake of it, we'll call that +5 and -5 and +5. We'll just give some numbers to it, right? So I don't have the scale on there, but let's just pretend that that's a -5. So plus or -5 centimeters above and below. And then you can back this up again. So visually, why are we giving that estimation of plus or -5 here? Yeah, it could be anywhere, but the reason I'm giving you that range is because when I look at the graph, I can visually see that around that age of 0.5, there's roughly a scatter. You know, for the whole first year, the scatter throughout that range is roughly plus or minus 5 centimeters above and below that line. So I'm guessing that any of my predictions within that range are going to have a range of plus or minus 5 centimeters, right? So use that as your visual. So because the scatter from 0 to 1 years is roughly plus or minus 5 centimeters, this is why I'm giving you the range of this, okay? If you go on to make another prediction, something like, I don't know, 5.5 years, you're going to pick that one off, but what's going to be your range here, and how would you describe that?
Quite a big range because the scatter in that part of the graph is quite large.
Yes. Sorry, trying to get that turned off. So it is going to be a much bigger range because the scatter from that point on is how much? Like if this little bit along the trend line was plus or minus 5, how much do you think this scatter is? Yeah, maybe plus minus 10, maybe plus minus 15. Take a look at it. And we're trying to pick off things that are relatively above and below. So here I'm actually noticing it goes a little bit further down below. But if we said plus or minus 10 for my range, you know, then I can say here I'm going to give myself a range of plus or minus 10 centimeters for the height of that pony in Texas, because the scatter generally after the first year is kind of about 10 centimeters above and below the line. And then in this case, you could even go a little bit further, but I do notice actually that there's more scatter below out here. So it's possible that maybe my prediction is actually going to be a little bit higher than it might be in real life, because I do notice that there are a few more ponies with the shorter values there than the taller values. Okay, see how that scatter is spread further down below the line? So again, I'd give the same range of plus or minus 10, but you can say because I notice that the scatter is actually a little bit further below the line the whole way through there, my model might actually be predicting too high for me. You know, or might be predicting higher than what the actual middle of that range is. Yeah? Questions on that?
Just about predictions, when you're picking a value
Almost. Try to give yourself something interesting to talk about. So pick one that's reasonably a good prediction or strong, and that's kind of like our 0.5. This one's got a lot of good scatter, lots of other points to base it on. This one at 5.5, there's not many other points out there. There's a lot more scatter. If you wanted to, you could even go further out and say like, well, what about a 7-year-old pony? How much scatter would they have? And you could get into some ideas about research here. Like really, I mean, why has the graph leveled off? Yeah, most things don't grow forever, right? So ponies will grow, and I don't even know, maybe it's like, I think horses keep kind of growing for a few years, but I don't know ponies well enough, so I just kind of estimate it in there. But you could do some research and say that ponies usually reach their maximum height by the age of 2, so I'd expect that scatter to stay the whole way across. And really, my prediction for 4 years and my prediction for 5 years and 6 years and 10 years might be the exact same, because technically they shouldn't be growing anymore. And so you could guess further out and then get that research, that context, that idea that the height of a pony won't actually change. So the further out I go. And in a way, that's also something that we call that there's no correlation at all, because at a certain age, does it change their height anymore? So where is the actual correlation here happening? Like, where is the influence on age and height occurring? Yeah, so you know, maybe it's the first 3 years where we actually see a strong influence of the age of the pony and the height of the pony. And that's where we see more of what we would call the correlation, that influence. But afterwards, if the pony isn't growing anymore, does it matter how much older they get? So does it make sense to say a statement like, for every year the pony gets bigger, or for every year older the pony is, it grows by 7 centimeters? No, right? So there's at some point where that idea of this thing continuing to change isn't going to make sense anymore. So you could say that correlation has a limit. It only kind of works up until the mature age of the horse. And then it's not going to matter because the horse isn't going to grow. In fact, it might shrink a little bit with age or something like we do, right? So those are some interesting things to think about in terms of, like you talked about with the Honda cars, like they should level off. The price will probably reach about the same. So in a sense, it really won't matter how much older the car gets. Or in that case, even some of you guys picked up on the idea that the older the car gets, it might get into a vintage class and actually become an increased price again because it becomes an antique thing. Horses will probably just die. They won't become vintage ponies. But, you know, that idea, take a look at your data set. And same with the health and wealth. Like at some point, you'll see those graphs level off where like you could give each citizen another $1 million. Is it going to actually change where they are? If they already have $1 million each, or if they have $5 million each and you give them another $500,000, does it really affect their, you know? So where is that relationship actually having the biggest effect? And it's usually on these nonlinear ones at the start where you see that rapid increase. Once things level off, then that change doesn't really matter that much. Because some of those graphs too are like the life expectancy. So I don't know where I have that one to look at, but the life expectancy graph does something like this. Can you guys see that? So this is like GDP per capita, and this is life expectancy. So where does having a higher GDP help you? Like where would it make the biggest change for somebody? Like if somebody was here and they could go to here, would that have a big change for them? Yeah, so those are the poorer countries are the ones you want to get the money to because that's going to have the biggest impact on their life expectancy. But for some place like out here, if you give them an extra $500,000 each, does that change much for them? Not really. And so that's kind of this idea that for the nonlinear, you know, where's that change actually going to have the biggest impact? And it is usually on where the ramp is biggest, whether it's going up or going down. But once things level off, we don't see that relationship so much anymore. We're like, I can continue to give you boatloads more money, but it's not really going to have much of an impact on your well-being at that point. Right? Or I can keep a pony well fed, but it's not going to make it any taller, you know, that kind of idea. So think about that in the context when you guys are looking at these.
Is there the opposite ones that are flat and steady?
Like this?
Yeah.
I'm sure there could be. I can't think of any examples we would have given you like that, but I guess it could be possible. But that would be the idea that, again, here, there's actually no change. If I go from 0.1 to 0.2, my whatever this is, my y value hasn't changed, so it's not really having any impact on me up until the 3rd year, and then after that, yes, I do see that it's going to have an influence on me quite dramatically. Yeah? I don't know, can you guys think of a story that would go with this graph? What starts off high and drops down? Yeah, bankrupt or corrupt. This isn't really true, but I was kind of thinking about it from like I don't know what the right word is for that, but like relationships or like marriages or things, like starts off all fine and then, you know, for some it just goes downhill after a point. Others might, you know, stay fine or go up or whatever, but, you know, you've got this idea that things in this graph, things are level and steady at the start, and then you have this rapid decrease off afterwards.
What if you had one like that, but then one of the ones went up and another went down?
Like this?
Yeah.
Yeah, so like if you were talking about groupings, like maybe this was all the males ended up here and all the females ended up down here.
Yeah, or if it was like skydiving in relation to oxygen levels or something like.
Yeah, so if this was my data set and I plotted it all at once and I saw there was actually a total divergence here, part of the data went up, part of the data went down, this would be a great place to like subset your data. Because clearly, outside of this range here, you've got a very different prediction based on whether you're male or female. And so if you go back into Excel and subset your data, you can get a totally different trend line for your males and a totally different trend line for your females. So you would use that to make completely different predictions. So I would predict for males in year 6, they're going to have a value of like 400, and females are going to have a value of like 0.1. Okay? So if you know which group you're predicting for, you have a much more accurate prediction. Versus if I tried to use this data combined, my trend line would do something like through the middle, and it's not really fairly representing those groups after a certain point either. So they talk about that, this idea that you can subset your data and make predictions better for one or another, depending on the situation, depending on which one you're predicting for. Yeah? Have you guys looked at ones like that, or you okay? I'll just show you an example of that real quick, maybe. So this is the bones practice task again, which some people are going to skip, and like I was saying, I think the weather one is better than this one maybe to do, just because the exemplar for this is good, but the other ones kind of fit more with what we generally get into. So this is dead people, right? And it's the length of their femur and their height, and you can see it's a pretty strong trend. But if you carry on and do a little bit of investigation, you can actually break that data out into ethnicity. And if you make a new trend line for each ethnicity, you've got a much accurate prediction than you do for the whole, because the original trend line went like just, oh, that's huge. The original trend line did something like this, kind of through the middle. But if you use a prediction for the, okay, say that you have a missing Caucasian, you could use the Caucasian trend line there. It's going to give you a more accurate relationship for a Caucasian femur to height ratio than it would for anything else. So yeah, that's when you can get into it a little bit more detailed. Yeah? Other questions? Okay then.